Hey everyone, welcome to my YouTube channel. So today we are going to discuss the most important problem, of binary search plus 2D matrix. That is search in a sorted 2D matrix. It is the most important problem. You can see it is a moderate level problem, not easy level. Fine. And why this is the most important? Because there are two main reasons. First is I have seen this problem in a lot of companies. Okay, a lot of MNC companies plus FAANG companies also. I've seen in Amazon and Microsoft the concept using which we are going to solve this problem. On that concept they have asked the problem. Okay, and the second thing is we are going to use the best algorithm to solve this problem, which will pass all the test cases. Okay, so you can solve this problem using O of n square time complexity also, but it is not recommended. Not recommended. Okay, so we are going to solve using log of mn time complexity. M and n are the number of rows and columns, and it is the best algorithm. Best algorithm. Okay, so first let me open my open board. Okay, and let me explain you step by step so that if any problems comes like or if this problem encounter in any interviews, then you can solve easily. Okay, so fine. Let me open my open board and let me put the heading as search in a 2D matrix. Okay, fine. Now you can see you are given a 2D matrix. Let's read the problem. You are given a 2D matrix. Okay, n into m. Fine, n into m means there are rows and columns may differ. Okay, you must check whether the given target element is present in a matrix or not. Target element is given. We need to check if it is present or not. That's why it is returning the boolean. If it is present, then true, else false. Okay, but we will solve. Before solving this, first we need to return the index. If suppose in place of boolean they ask you like return a 1D array, in that you need to return row and column x and y of target. Then so first we will solve this, and then it's this boolean one is very easy. Okay, you just need to return two true and false on base of condition. Okay, so the following properties: each row integer sorted from, okay, that means they are sorted from left to right. Okay, fine. And the each row first integer greater than previous last. Okay, that means increasing order. So the examples are 1 3 5 7. Okay, you can see these are the examples. 1 3 5 7 and target is 3, so 3 is present, yes, so it returns true. Okay, and the index should be 0 and 1. You can also see the few companies: phone pay, JP Morgan, CIS, infrastructure, cyber. Okay, so let's understand this code. First, let's take 2D matrix. Let's take 2D matrix. Okay. Hmm, okay. 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 Hmm. Let's take the same example: 1 3 5 7 10 11 16 20. Okay. 1 3 5 7 10 11 16 20. 1 10. 1 3 5 7 10 11 16 20. Okay. 23 30 34 60. Fine. 23 30 34 60. Right? Yeah. So the rows are, number of rows are 3 and columns are 4. 3 into 4. Okay, don't worry. Okay, so it's already written previously that n into m. Okay, not n into n. So n into m, right? Okay. So n is number of rows, which is 3, and m is number of columns, which is 4. See, before solving it, I'm hoping that you have already seen my 1D array, binary search in 1D array. Okay, if you haven't watched, then please go and watch it, because It is completely related to binary search in 1D array. Okay, yes, it is a clever idea. That is a clever idea of the algorithm. Why this is the best algorithm? Best algorithm. Because a clever idea we have used. What is the idea we have used? That we have assembled the complete elements of 1D array from 0 0 to length. That means from 0 0 to length. That is uh, 0 1 2 and 0 1 2 3. Okay, so 2 3. 0 1 2, 0 1 2 3. Okay, so up to this element we will assemble all the elements in 1D array. Okay, and then we will apply a tactically binary search. Okay, and it's a super simple and great algorithm. Okay, so if you don't know like how to apply binary search in 1D array, then please don't watch it. Okay, first you need to just see it. Okay, so in brief, how to apply binary search in 1D array. Suppose you are given 1, 2, 3, 4, up to 20. Then the first thing you'll calculate the mid element. Okay, and then you'll check if my target, suppose my target is 3. So if my target is greater, less, or equals ARR of mid. Okay, and according to the condition, you will return the answer. That is, you will return the index number. Okay, index number of target element. Okay, this is clear. This is clear. Okay. Now I've told you that okay, assemble. I've given you task. Okay, just follow my task. I've given you task that okay, assemble this array, this 2D array from 0 0 to 2 3 at the end index. Either it is 2 3, either it is 3 3, or the last element, the last corner element. Okay, assemble those all the elements in 1D array. Flow should be like this: left to right, left to right, left to right. Okay, 1 3 5 7 10 11 16 20 23 30 34 60. So okay, fine, you started writing the elements in 1D array: 10 11 16 20 23 30 34 and 60. You have assembled. Very good. Super. Okay. Now you have asked me like we have already write the element in 1D array. Okay. Following this flow. Left to right, left to right, left to right. Fine. In ascending order. It is ascending, right? 1 3 5 7 till 60. Okay. Now, now what is our target element? Our target element is 3. Target element is 3. Okay. It's 3. Oh, overwriting always 3. Fine. Now target element is 3. Okay. Where is the 3 here? And if I told you that your job is to return the index of target element. So what is the index? 0 1, 0 1. Index of 3 is 0 1 only. 0th row, first column. Okay. Now just listen carefully. Okay, if you are using phone or anything, just keep it away, switch it off. It's a most important algorithm. Okay, so the target element, okay, the target element index in 2D array is 0 1, and that is what our task we need to return. Okay, now let's move to 1D array. 1D array, all the elements of 2D array we have assembled as a 1D array. Okay, where is our target element? What is the index? 1. Okay, but we should not return this index. Okay, it's a 1D array index. In actual, 2D array is given to us. Okay, and we need to return. The main answer is 0 1, not the 1. Okay, the main answer in the form of 1D array. Okay, we need to return new integer. Okay, and 0 and 1. Fine. This should be the answer: 0 and 1. Zeroth column, first, zeroth row, first column. Okay, very good. So let's take this array. Let's take this array to the next page. Okay, fine. This was our array. Okay, now this is a target element. Okay, I'll write target as 3, and let me take that element also, right? Let me take 2D also. Okay, good. And it's a target element. Now, suppose if we will apply binary search in this 1D array. How to apply binary search? Calculate the mid. Okay, mid is S is 0 and end is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so S plus E minus S upon 2, 0 plus 11 minus 0 upon 2, 11 upon 2, that is 5 in an integer. Okay, so 0, 1, 2, 3, 4, 5. This is our mid. Okay, fine. This is our mid. 11. Now, just we have calculated the mid. We want to calculate one more thing. Very, very, very important step. Very, very important step. Star, star, star. Why? Wait. We have already calculated the mid index. Okay, 5. Now, how we can use this 5? Just think once how we can use this 5. We can't use it. Why? Because the assumption, this 1D array is our assumption. I've already told you that let's assume that we have assembled all the elements, we have flattened 2D array. We have assembled all the elements in 1D array. Okay, we are not going to create a 1D array explicitly and then store all the elements in that. It will get worse, our time complexity. So this is the variable, the another variable int mid element equals ARR of mid divided by number of columns mid modus number of columns. This gives me actual element because it is because it is this complete part giving me row index and this complete part giving me column index. The most important step. Why we have calculated that? Why? Because see, we want the mid element. We want the element to which we can compare our target element. And we need to find the actual element. How to find actual element? This is the formula of actual element. And then the same thing apply. Using start and end, we have calculated the mid element in the 2D array. This is the most important step. The most important step is using just start and end. We have calculated the array element, the mid element. We have located the mid element in the 2D array. Okay, let's solve this. It's very super interesting. Let's solve this. Page. So this is our equation. And to solve this, what is mid upon number of column? Mid which we have already calculated. Number of column means ARR of 0 dot length. In array, what is the number of column? ARR of 0 dot length. Number of rows, ARR dot length. Getting? So, what is mid? 5 upon number of column. How many number of columns? 1, 2, 3, 4. 4 columns. 4. It gives quotient. What is the quotient? 1. See the magic. It is the first result. Second result, this one. Mid modulus number of columns. Mid is 5. Modulus, I told you, modulus gives us remainder. Modulus gives us remainder. Number of column is 4. What is the remainder? What is the remainder? 1. Okay. ARR of 1, 1. ARR of 1, 1. What is ARR of 1, 1? 11. 11. Okay. What is the mid? Mid is 5. Okay. 0, 1, 2, 3, 4, 5. 11. Fine. Now why we have calculated 11 using this formula? Why? Because it's our assumption. 1D array is our assumption. It's a hypothetical. We have assumed that okay, let's flatten 2D array in the form of 1D array. Let's assemble all the elements of 2D array in a 1D array. Why? Because we need to calculate the mid element. Why? Because we want start and end index in which we can solve, we can apply binary search. I told you that in many of the cases, direct 1D array is not given to you. Direct sorted array is not given to you. You need to brainstorm. That's why, and what is 1D array? What is the binary search? Start and end index. If you got a start and end index, rest all the same. Target is given. You have brainstorm, start and found. What left? Nothing. That is why we have assumed 1D array. We got start 0. We got end as 11. We have calculated mid index. We have calculated mid index. Now using that index, on that index, what is the element in 2D array? What is the element in 2D array? Okay, so how to calculate that? How to calculate that? Using mid index. That is why we required this 5. Mid upon number of columns, mid modulus number of columns. It gives me the array present in 2D array. See how what an important step is this. We assume 1D array, start and we have calculated mid index. Using that mid index, we have calculated the actual position of the element mid element in 2D array in the main array. How important step is this? Now the rest thing is same. Program over. Program over. We have calculated. We got the element. Okay, this is ARR 1 1. So we got mid element as 11. The next step is if my target greater than mid element. That means if my target is 3 is greater than 11, condition false. Okay. The second condition, if my target is less than mid element, that means if my target is less than mid element. Okay. And what are these conditions? These are 1D array condition, man. We have already discussed. Okay. If you haven't watched, then please go and watch. I'm not going to just tell again and again. Binary search in 1D arrays. Okay. Then something. Condition true. So if this condition is getting to target is 3 and mid element is 1, we have already seen 11. Okay. So in this case, if target is less than, then and equal mid minus 1. In this case, s equals mid plus 1. Else return new int these two. Mid upon number of columns, comma, mid modulus number of columns. It is not modulus, it is upon. Divide. Okay, why? These are only the indexes, na. See, if our target element is 11, 11 only. First step, we have assumed that okay, let's flatten the 2D array in a 1D array. Okay, fine. So that we got start and end. Okay, start got, end got. We have calculated mid index. Mid index is 5. Fine. Now we apply the formula mid element. Okay, because we want what are the element present at that index. Okay, in 2D array. We apply the formula mid upon number of columns, mid modulus number of columns. Okay, we got 11. We got 11. Fine, because in index 5 it is 11 present. As per this formula, we got 11. Okay. Now next, we are checking these conditions. Target greater than no. Target is not greater than target is equal because target is 11 and what we got mid element 11. Target less than no. Else return new int. This is we have created 1D array. Okay. And in 1D array, we need to return indexes, row and column. What is a row? 1. What is a column? 1. That's why we need to return these two. Simple. Over. This only we need to do, right? Get me the index of element, target element in one in 2D array. And the same thing. This in this question, it is asking Boolean. That means if the my target element is present in the 2D array, then return true else false. So it is more simpler. It is much more simpler. Instead of this, just return true. Out of the loop, return false. Simple. This is the most important step. Most important step. And using this step, this is why this is because see, we are calculating mid element, but we will calculate start and end. Okay, from 1D array, and using that, we are calculating the position. This is the position only, right? Mid upon number of columns, that is 1. The row and column we are calculating. Okay, and we are calculating row and column using this mid index. That means actual position in 2D array. See how important step is this. Okay, so this is what next, and the final thing this is. Now the only remaining thing is code. So let's code it. Okay, let's code it in a quick manner. And you'll see whatever I explained you, same thing I'll copy it and paste it. Nothing change. No change. No change because I haven't left anything. Okay, so let me open my Eclipse. See, we will do this program just after when I write the. See, we will do this program. Okay, but first we will implement our program in my Eclipse, in my IDE. Then we will jump here and then solve this. This is the formality. Why? Because we need to see using debugging also, right? So I already created a class searching 2D matrix. Okay, I'll create a main method. Oh, main is already created. What is happening to me? So let me create a 2D array. 2D array 1357. Hmm. What is the array 1357? 10, 11, 16, 20. 10, 11, 16, 20, 23, 30, 34, 60, right? Int target equals, what is the target? 3. 3 is the target, right? 3 is the target. 1, 3, 5, 7, 10, 11, 16, 23, 30, 31. Okay, fine. Same array we have taken. Good. Let's create a method. Target index of target element. Index of target element. Find index of. Find. Where pass array and obviously target. Let's create the same method. Static We are returning 1D array because we need to get row and column indices, store in 1D array and then return it back. Okay, fine. Same method. What we are getting 2D array, ARR and target. Okay, fine. Now the very first thing what we have done, we have assumed, okay, let's assumption done. We want start and end. We want start and end. What is the start? What is the start? What is the start? Start is 0, always 0, the first 0. What is end? Number of rows, 3. Number of columns, 4. 3 into 4. 3 into 4, 12. 12 minus 1, 11. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Done. If suppose 4 into 4 matrix, number of rows 4, number of columns 4, 4 into 4 16, 16 minus 1 15, and will be 15. Start is 0, find and is number of columns. What will be the number of columns? Let's create another variable of columns and rows. Suppose m is number of columns, number of rows. So arr.length gives us number of rows. What gives us number of rows? Columns are arr of 0, 0 dot length. Okay, now if you don't know like how we'll getting number of columns in arr of 0 dot length, then I've already explained this in linear search last part of linear search in the past video. Okay, there I completely explained like what is 2D array and why we will consider these conditions and how to iterate. What are the steps to iterate? Okay, so there if you haven't watched, then please go and watch. Link is in the description. Okay, complete playlist link. So this is number of rows into columns minus 1. Fine. So here we got n. While traversing from start less than equals end. Okay, we need to, because see, if our element will present, if our element target element is 3 and if it is present in 2D array, okay, and we have completely flattened 2D array, that means it should be in the range of start and end. That's why we are just checking in it. Okay. Next thing. The next thing is what we are doing. Calculating mid and mid element. Yeah, let's calculate mid equals same start plus and minus start upon 2 mid element equals ARR of mid divided by, okay, while debugging mid, okay, while debugging I'll stop the control here and then I'll show you the indexes, separate indexes. Okay, so that will be interesting. Mid upon columns and mid modulus columns, COLS. Getting a point? Here we have done right. Number of columns, modulus divided by. Okay. Then what we have done? Then what we have done? These are the next steps. And then target greater less than or equals. Simple. Okay. Then if my target is greater than mid element, if yes, then start equals mid plus 1. If target greater than, then start equals. If target is lie here, then we need to move this start. Yes. Okay. Else, if target is less than mid element, then and equals mid minus 1. Okay. Else, return new int row, row index, column index. Got it? What I have done? If the array is not present, then return empty array. Means not empty array, the array with value minus and minus 1. Fine. Okay. Can we run it? Everything is done. Yeah, we need to print it. How we can check? We need to print the array. What we got. So how to print the array? I already explained you a lot of number of times. Array dot to string. We need to print one D array, right? Why? Because we need to check the output. What? Why? Okay. So let's run Java application. Target is 3, so our answer should be 0, 1. 0 throw first column. 0, 1. Okay. If my here it should be 30, not 20. It is increasing given in the question. It is 30. Oh, Eclipse. If I write here 30, then answer should be 0, 1, 2, 1, 2, 1. 1. 60. Then 2 and 3. 2 and 3, right? 2, 3. 600. Minus 1, minus 1. Not in the 2D array. Minus 1, minus 1. Okay. Now just copy the same. Okay, first let's debug. First let me just copy this. Copy it. Okay. Copy it. Paste it. Just change return to here true, because it is taking true and false. If it is present, then we should not return the index, just return true and false. Else false. Okay. And return this. And what is the 2D array? Matrix. One thing I haven't discussed. What is the one thing? Wait, before running it, we need to add one check. Suppose our array is null, then number of rows is 0, then number of columns is 0, then so that is why we need to add the check. So what is the check is if arr dot arr equals null, or if arr dot length equals 0, or if arr of 0 dot length equals 0. That means if arr equals null, or rows are 0, or number of columns are 0, then just return new int -1 comma -1 here. Okay, suppose the array is null, then run as Java application, right? -1 if I comment this, okay, then exception, null pointer exception in the 17. Why 17? This because arr is null, so you are applying the method on null, that is give you null pointer exception. Fine, that's why we need to add the check here. So the same check we need to add here. Okay, in this case return false. One thing, boolean. Okay, it is returning boolean. So can we run it? ARR target. Okay, let's run it. All test case passed. Let's submit the code. Accepted. 5% 0.82. Memory is very less. All 12 test cases passed. Now let's debug it. The final thing, let's debug it. Debug pointer here, here, and here. So let me array is null, right? Now it's okay. Not 600. Let's take 3. Debug Java application. The control will definitely stops here because there is one debug point, breakpoint. Okay, there is one breakpoint. Control breaks. Let's okay. AR equals null. No, no, no. All condition false. Rows are number of rows 3. Okay, 3. Number of columns are 4. Okay, you can see 1, 2, 3, 4. There are 4 columns. Fine. Start is 0. Rows into columns 12 minus that is 11. You can see 11. Okay. You can also check here. There is one properties section. You can see. And that property is console breakpoint. Okay, leave. We can hover and then inspect. Start 0 and is 11, obviously. Condition 2. Mid is 5. Okay. Start plus end upon 2, that is 11 upon 2, 5. Okay. The same thing we got here. The first case 5. Okay. Now let's mid upon calls. Inspect it. 1. Okay. We already calculated this for this, right? 1 upon 4, 0. Sorry, not 1. 5 upon 4, right? 5 upon 4 is 1 and 5 modulus 4 is 1. Okay. So AR of 1 1, that is mid element. What is mid element? 11. Okay, 11. Fine. Target is greater. What is the target? 3. 3 is not greater. 3 is less. And equal mid minus 1. So now n becomes 4. See here. And was initially this. Okay, and mid minus 1. What is the mid? Mid is 5. So 5 minus 1, 4. Now n becomes 4. Now it will check in this part. Means we are going right. We are just close to our target element. Again the same step. Okay, calculated the mid, that means 0 plus start is 0, 0 plus end is 4. 4 upon 2, that is 4 only, right? Sorry, 2 only. 4 upon 2 is 2. So mid is 2. Now 2 upon calls, 2 upon number of element. Okay, so let's solve here only. Fine. So in this case mid is 2. So 2 upon what is the calls? Means what is the number of column? 4. Okay, fine. So what will be the quotient? Quotient is still 0. Okay, quotient is 0. And what is the remainder? 2. So 0 2 will be our mid element. What is present at 0 2? 0 1 2 5. So our mid element will be 5. Let's check in 1D array. Mid element will be 5. Yes, we are getting close. See the algorithm is how algorithm is working. 5. Okay. Now target is 3. 3 is greater than 5. Yes, 3 is greater than. Sorry, no, 3 is not greater than 5. 3 is less than 5. Again, and equal mid minus 1. Okay. Now, and is this 4 and mid is this. So mid minus 1. That means and comes here. So start equals end. Start comes equal end. Okay. What is the end? End is 1. Start is 0, right? No, no, start is not equal end. Start is here only. Okay. Or end comes on our target element. Fine. Mid is this mid minus 1. That means end. Mid is 2. So 2 minus 1, 1. Which is our end. Okay, fine. So calculated mid 0 plus 1 minus 0 upon 2, that is 0 only. Okay, 0. Now, if mid is 0, so 0 upon 4 and 0 modulus 4. 0 upon 4 is 0 and 0. And 0 upon 4 is 0 modulus 4 is 0. Okay, and ARR of 0 and 0. This, right? We got 0 0. So ARR of 0 and 0. So what is ARR of 0 0? ARR of 0 0 1. Okay. So our mid element is 1. Fine. Now target, which is 3, is greater than 1. Yeah. Now it is 1. Now it is greater. So start equals mid plus 1. What is the start? Start is 0. What is mid? Mid was mid was 1, right? No, mid was 0. So start equals, now start becomes 1, right? Because initially start is 0 and this condition got true. So start equal mid plus 1. Mid was 0. 0 plus 1, 1. Okay. And was at the 1 only. Okay. So start is less than equals to end. Yes, condition true, because you can see, right? Start comes here and end was here only. So now the condition came where start equals end. Okay. Start is 1 and is 1. That means mid is also 1. Definitely. Mid is 1. Okay. So in this case, 1 upon 4 and 1 modulus 4. 1 upon 4 is 1. Sorry, 0, 0. And 1 modulus 4 is 1. 0, 1. What is ARR of 0, 1? ARR of 0, 1, 3. Okay. Mid element is 3. You can see what is the mid element? 3. Okay. Target, that is 3, is greater than 3. No. Is less than 3. No. Equals 3. Okay. Equals 3. So if it equals 3, create an array. Okay. Create an array, 1D array, in which store the indexes of 3. What are the indexes of 3? We have calculated already here. 0 and 1. This one. This 0 and 1. So 0 and 1. You can just also do it. First, let me erase this. You can also just right click, inspect, 0. And 1. Okay. Just return it and then printing it. Rest all is 0 and 1. So we have done um, sorted in 2D matrix. Okay, we have also implemented this code in our main program and we got the passed all test case. Okay, this is a moderate problem. Now we have already completed the sorting lectures. Okay, so we are going to start a new playlist, problems of sorting, where we will see the bubble sort, okay, insertion sort, fine, selection sort, and the cycle sort. Cycle sort is remaining. After that, we are going to solve the Facebook, Amazon, Google, Microsoft problems as we are solving in binary search. Okay, now just understand the flow of my teaching. I'll teach the complete concept using debugging in pen and paper from debugging in the code. Okay, then I create a playlist of that topic, and in that playlist we are going to solve from easy to medium to hard problems to build the intuition, like how you can solve, how you can think. Okay, the question comes first, you need to just think like, yeah, I need to use binary search, linear search, or any search. Okay, so this is what we have done in this video. Let's see in the next video. If you like, then please comment down. See, comment is very necessary. Comment down and then subscribe. Thank you.